Okay, hello, mini Mathletes. We're fresh out of the meeting of Tuesday, December 15th, where we talked about some checkerboard questions and coins. And we unfortunately ran out of time before we could do some Math Kangaroo review. And like I told you guys, I'm going to be putting out a practice test for you to work on over the next week, maybe 2 weeks if you need more time. And so what I want to do in this video is give you some practice problems that are related to the ones you're going to see in the test that I post later today. And hopefully that will help you guys figure out maybe how to solve some of those questions or what sort of ideas you should use when you're thinking about them. So let's jump into the problems. This first question says, here are some words: duck, crate, apple, application, and lemur, and we want to sort them in alphabetical order from left to right. Okay, well, if you know what alphabetical order is, then you should pause the video and try to sort them on your own. Otherwise, I'll tell you what it is. We have the alphabet, which goes A, B, C, D, E, F, G, and so on. And when you sort words in alphabetical order, what that means is you would put a word that starts with A before a word that starts with B. And so the word armadillo would come before the word bone. Now, if two words start with the same letter, like armadillo and ape, then we look at their second letter. So armadillo starts with R, and armadillo's second letter is R, and ape's second letter is P. And we can think what comes first, P or R. It would be P because we go elemento P, Q, R. All right, so P comes first. And so that would mean that armadillo comes before ape. But since ape starts with A, bone starts with B, ape comes before bone. So that's what it means to sort things alphabetically. And with that in mind, now, since everyone should know what alphabetical sorting is, you can pause the video and try to sort the words on your own. And now that you've tried it, what we're going to do is we can see two of these words start with the letter A. So they're going to come first because A is the first letter. Okay, so we have apple and application. Now this is tricky because they have the same first letter, which is A. Then they have the same second letter, P, the same third letter, and the same fourth letter. So we have to look all the way at the fifth letter, which for apple is an E, and application is an I, and see which one comes first. So what comes first, E or I? The answer is E. Okay, and so that means that the first word in our list will be apple. And then the second word is application. And remember, we know those come first because they both start with A, and A is the first letter, so it comes before everything else. Okay, now we can see, are there any words that start with B? No, and we check B because that's the next letter of the alphabet, right? Then we can check for words to start with C, right? And we see that crate comes next. There's only one word that starts with C, and so the next word in our list is crate. Another thing we could do is we can say we have three words left, which are duck, crate, and lemur. And if we look at their first letters, there's a C, a D, and an L. And C comes before D, D comes before L. So we know that the last three words are crate, duck, and lemur. And yeah, if you look, we had a little bit of progress already done. Lemur started off in last and stayed the last word. So that's how you sort the words in alphabetical order. Okay, on to question 2. If I start counting from 1, what is the 37th number that I'll say? What if I started counting from 2 instead? What about 11? So again, pause the video, try to figure out the question on your own. And once you've done that, you can hear what I have to say about it. So I'll give you a couple of seconds to pause. Okay, and now we will talk about this question. So if I start counting from 1, Well, I'll say 1, 2, 3, 4, 5, 6, and so on. And so the first number that I'll say is 1. So I can say first is 1. The second number that I'll say is 2, right? 1, 2. Okay, the third number is 3. The fourth number is 4, and so on. Okay, well, I'm sensing a pattern here, right? I see 1, 1, 2, 2, 3, 3, 4, 4, right? And so if the first number is 1, the second number is 2, the third number is 3, fourth number is 4, well, then it reasons to say that the 10th number would be 10, and the 20th number would be 20. The 23rd number would be 23. And so the 37th number would be 37. Perfect. And this should make sense. So all we're really doing is we're looking at the numbers and we're pointing at them, and we're just saying 1, 2, 3, 4, 5, 6, 7. Right? That's all we're doing when we're counting, starting from 1. Okay. What if I started? Oops. What if I started counting from 2 instead? If I start counting from 2 instead, well, then I'll basically just shift everything, right? Now, if I start from 2, then I'll say 2, 3, 4. And so the first number I say is 2. The second number would be 3. The third number would be 4. Fourth number would be 5, and so on. And so what I have now is 2 is just the number after 1. It's 1 more than 1. 3 is 1 more than 2. 4 is 1 more than 3. And so on. So all I did was I shifted all the numbers up by 1. And so what that means is that the 37th number that I'll say is 38. Now, I would advise against actually counting to 37 numbers to figure out a question like this, right? So if I started from, let's erase some of this stuff. If I started from 11, you shouldn't actually count up from 11 and try to figure out what the 37th number is. What you should do instead is know that if we start from 11, then the first number would be 11. The second number would be 12. The third number will be 13. The fourth number would be 14, and so on. And what we should notice is that 11 is just 10 more than 1. 12 is just 10 more than 2. 13 is 10 more than 3. So in general, I can find a pattern like this, right? If I started from 33, right, the first number I would say would be 33, and then 34, and then 35. Right? And 33 is 32 more than 1, 34 is 32 more than 2, and so on. So I can always find a pattern like this, and I can use this pattern to tell me that the 37th number would be 37 plus 10, which is 47. Okay, that's question 2. On to question 3. What number is larger than 8 by 13? What number is smaller than 13 by 8? What number is larger by 9 than 11? What number is smaller by 30 than 42? And what number is larger than 21 by the number that's smaller than 34 by 9? Okay, a lot to understand here. Most of this question is figuring out what all the words mean when you put them together. So let's look at this first question. What number is larger than 8 by 13? Well, that means that if I start from 8, then to get to that number, I would need to go up by 13. Okay, so if I start from 8 and I go up by 13, what that actually means is I take 8 and I add 13. Right? 8 plus 13, you can pause and try and figure it out, is 21. Right? Something else I can do is if it's larger than 8 by 13, I can start from 8, and make sure you don't say 8, but start from 8 and you say 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 13 more than 8 is what is meant by what number is larger than 8 by 13. Okay, so that first one is going to be 21. Perfect. Okay, let's make this small. Okay. What number is smaller than 13 by 8? Okay, well, what this means is that to get that number, if I start from 13, I would have to go down by 8. So I would go from 13, and then I would go 12, 11, 10, 9, 8, 7, 6, 5. So I want the answer to be 5. And what I can do to make it a bit faster is 13, right? I start from 13, and then I go down by 8. That just means subtract 8. And so 13 minus 8 is 5. Okay, awesome. Okay, next. What number is larger by 9 than 11? Well, the only thing that's really different about this question from the first one, apart from the numbers, is that I switched the by and the than. So I could just as well say, what number is larger than 11 by 9, right? And what this sentence means, just like in the first sentence, is that if I start from 11, then in order to get to that number, I would need to go up by 9. Okay, so I'll leave the counting up to you if you want to do it. I'll just do the addition, and I know that that's going to be 11 plus 9. 11 plus 9 is 20. Okay, so far we figured out 21, 5, and 20. Awesome. Okay. What number is smaller by 30 than 42? I think what I'll do is I'll leave this one to you guys to figure out, and I'll go to this last one, which has some really challenging phrasing. There's a lot going on here. I'm not a big fan of the semantics of this sentence personally, but let's look at it. What number is larger than 21 by the number that's smaller than 34 by 9? Okay. The biggest challenge, like I said earlier, in this question is figuring out what it all means, right? So it's saying this number is larger than 21. How much larger? Well, it's larger than 21 by the number that's smaller than 34 by 9. So I say this number is larger than 21. You say by how much? I say the number that's smaller than 34 by 9. Well, then I want to know what number is smaller than 34 by 9. So we have sort of a middle question. What number is smaller than 34 by 9? Okay, well, we did a question just like this. That was our second question. And so we know that we can use subtraction to solve a question like this, because we start from 34 and we go down by 9. And so that would be 34 minus 9, which is, you're welcome to pause and try it on your own. 34 minus 9 is 25. Okay, well, now what I can do is I can take this whole part here, the number that's smaller than 34 by 9, and I can just replace it. I can just replace it by 25. And so now the question is, what number is larger than 21 by 25? And again, we've seen a question just like this. It was this first question. And we know we can use addition to figure that out. So if this number is larger than 21 by 25, then all we need to do is say 21 plus 25 and that gives us 46. So that's our answer to most of this third question. Okay, number 4. Number 4 is a weird one. How would you match up the numbers on the top and bottom? So what I'm looking for here is a logical way of matching up the numbers. I personally wouldn't write a question like this, but there's a question in the Math Kangaroo practice test that looks vaguely like this. So see if you can find a nice pairing of these numbers and explain why it makes sense. So pause and play around with it. I'll give you a few seconds to pause it. Okay, now I will reveal the answer. If you're trying to match up numbers, one good thing that you can always try is just matching the smallest number with the smallest number, and then the second smallest with the second smallest, and the third smallest with the third smallest, and so on. And so that's what I'm going to try. We have 1 would match with 3. And you might be thinking, oh, but there's a 3 and a 3. We should match those up. And that may be. Maybe you found a matching that makes sense. For now, I'm going to try this out, and then I'll see once I'm done if it makes any sense. So we have 1 with 3. Okay. And so we've used up our 3. We've used up our 1. We just used up our 3. Okay. Now, what's the next smallest number? Well, that would be 2 on the top and 6 on the bottom. So we'll do 2 with 6. Oh, that's gross. 2 with 6. Okay. So let's highlight those. 2 has been matched. 6 has been matched. Okay. The next smallest numbers would be 3 on the top, 9 on the bottom. All right. 3, 9, and then 4 and 12. And 5 and 15. Okay. Great. So I matched up 1 with 3, 2 with 6, 3 with 9, 4 with 12, 5 with 15. Okay. So let's see if we can make some sense of this, because we have at the very least that the numbers are in order. But if I actually look more closely, I see 3, 6, 9, 12, 15. There is a pattern with these numbers. If you don't spot it right away, you should pause the video and try and figure out what the pattern is. So pause the video if you don't know. Otherwise, I can tell you that this is counting by 3s, right? And what that means is we have 3, and then 3 plus 3, and then 3 plus 3 plus 3, 3 plus 3 plus 3 plus 3, 3 plus 3 plus 3 plus 3 plus 3. And for those of you that know about multiplication, which will be all of us soon enough, that's 3 times 1, 3 times 2, 3 times 3, 3 times 4, and 3 times 5. Okay, so that seems like a nice enough matching, and we'll call it a day on question 4. All right, question 5. Today is Tuesday. It really is at the time of recording. What day will it be in 3 days? How about 70 days? Okay, well, you should pause the video and try to solve it on your own, but I'm going to go ahead and talk about the answer. So if I write out the days of the week, I've got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And what happens is, well, we can talk about that in a second, but if today is Tuesday, well, then tomorrow in 1 day, it would be Wednesday. In 2 days, it would be Thursday. And in 3 days, it would be Friday. Okay, well, that tells us our answer to this first question. I go 1, 2, 3 days forward, and I get to Friday. So in 3 days, it will be Friday. Great. Well, now we have something that looks a lot more difficult, which is what day will it be in 70 days? And there's a trick to this one. There's a tricky thing we can do, which is this. What happens when it's Sunday and we try to go one day forward? Well, you guys know the day after Sunday is Monday. Okay, so what happens is we go Monday to Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And then we go all the way back to Monday. And the way we can sort of understand what's happening here is we can draw a circle, right? We've got Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday, right? And they sort of make a circle. We go Monday to Tuesday, Tuesday to Wednesday, Wednesday to Thursday, Thursday to Friday, Friday to Saturday, Saturday to Sunday, and Sunday to Monday. Okay, well, how many hops or arrows do I need to follow to go around this circle once? Okay, so we remember that today is Tuesday. And if I go 1, 2, 3, 4, 5, 6, 7 arrows, 7 days forward, that will get me back to Tuesday. And that's, of course, true because there are 7 days in a week, right? So if we go through one whole week, we'll end up back at Tuesday. So after 7 days, I'm at Tuesday. Well, what that also means is that after 7 days and 7 more days, I'll also be back at Tuesday. So after 14 days, I'll be back at Tuesday, right? And then 7 plus 7 plus 7, that's 21. So after 21 days, I'll be back at Tuesday. So what we need to figure out is how many times are we going to go around that circle before we get to 70? Oops, that's not what I wanted to do. Before we get to 70 days. Well, 70, nicely enough, has a 7 right in it, which is sort of a hint at what's going on. Right? 70, if you remember our warm-up question from what would have been the second meeting, 70 is 10 plus 10 plus 10 plus 10 plus 10 plus 10 plus 10. Now, for you guys that know about multiplication, you know that 70 is 10 times 7, which would be 7 plus 7 plus 7 plus 7 plus 7, and then 7 plus 7 plus 7 plus 7 plus 7, right? And that tells you that we go around the circle exactly 10 times. I won't draw all 10, but if we go around the circle exactly 10 times, then we're going to end up back where we started, back on Tuesday. And so after 70 days, it will be Tuesday. Now, if you don't know about multiplication, it's a little bit trickier. But what we can do is we can say, okay, well, we know 70 is 10 7 times. Okay. So let's just draw 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. And we know that 70 would be 10 7 times. So I'll just take those dots and I'll make some copies. So we have 2 copies, 3 copies, 4, 5, 6, and 7 copies. Okay, and now here's the trick. The trick is that, look at this. We put 10 dots in each column. That's the vertical parts in each column. But if we look at each row, we've got 1, 2, 3, 4, 5, 6, 7. Right? So there's 7 dots there, 7 dots there, 7 there, 7 there, 7 there, 7 there. Perfect. Okay, and as it turns out, if you know about multiplication, you probably don't know Maybe you do, but you probably don't. Let's see. Two of you should. I know that. But if you don't know, this is sort of why the commutative, oops, I wrote the commutative property of multiplication. That's why that works, because I can draw dots in a rectangle, and I could look at the columns or at the rows. And so in either case, I can see that 70 days would be going around the circle 10 times. In other words, that's 10 weeks. And so after 70 days, it will still be Tuesday. Okay, great. So we figured that one out. On to question 6. There are 13 cars in the carpool line. I'm in line. There are 3 cars behind me. How many cars are in front of me? Okay, so it's a little bit tricky, but what we can do, and again, just as with all the other problems, you should pause the video and work it out on your own. But what I'm going to do is I'm going to draw these cars. I'm going to draw them in just circles because I'm not a great artist. You can draw them however you want. 6, 7, 8, 9, 10, 11, 12. No, I cheat. Oops. Yeah, all right, 13. 13 cars. And let's say that the front of the line is here. Okay, and I'm in line. There are 3 cars behind me. Okay, well, what we need to do then is go to the back of the line. And we know that if there are 3 cars behind me, those cars are the ones at the back of the line. So 1, 2, 3 cars behind me. And so that means that I am this car right here. And now the question is wondering how many cars are in front of me. Well, we can just count them. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 cars in front of me. And so that is our answer. All right. Question 7. Jeffrey, not me. Jeffrey is waiting in line for the bathroom. He is 4th from the front of the line and 5th from the back. How many people are in line? Okay, so this one is like question 6, but it's a little bit trickier. All right. So let's see if we can draw this line. So we know that Jeffrey is 4th from the front of the line. So let's say the front of the line is here. And there's someone at the very front. I'll draw people as boxes this time. And then there's the person who's 2nd in line, 3rd in line, and 4th in line is Jeffrey. Okay, 4th in line is Jeffrey. All right. It also says that he's 5th from the back of the line. Okay. Well, what does that mean? If he's 5th from the back of the line, how many people would be behind him in line, right? If we draw the back of the line, and let's ignore this for now. If we draw the back of the line, there's 1st all the way at the back, then 2nd from the back, 3rd from the back, 4th from the back, and 5th from the back is supposedly Jeffrey. So if we look, there should be 1, 2, 3, 4 people behind him. So be careful, this will trick you. If you're 5th in line, there's only 4 people in front of you. Right? If you're 5th from the back, there's only 4 people behind you. Okay, well now we can go back to our original drawing of the line. We know that there are 4 people behind Jeffrey. And so we can just draw them into our sketch here. 1, 2, 3, 4. Okay. How many people are in line? Let's just count them. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now you might have, when you tried to solve this question, and I hope you did, you might have said he's 4th from the front and 5th from the back. And so 4 plus 5 is 9. Or you might have said He's fourth from the front, so there's 3 people in front of him. He's fifth from the back, so there's 4 people behind him. And so the answer is 7. Well, if you did this first thing of fourth plus fifth gives you 9 people, then you accidentally counted Jeffrey twice, because what you would have said is he's fourth from the front and fifth from the back, like this. And then you counted Jeffrey twice. If you did that second thing of 3 people in front of him, 4 people out behind him, you're maybe closer or on the right track. But in that case, you forgot Jeffrey, because you counted all the people in front of him, you counted all the people behind him, but you forgot Jeffrey himself. So that's how you can mess up that question. And these questions about lines and how many people are in them are really tricky. Okay. Let's not use the same. Okay. Number 8, how many numbers are less than 100? And we say no negatives, no decimals. So what I mean is if I just count, and I guess you can include 0, let's say other than 0. So if I count 1, 2, 3, 4, 5, 6, and so on, how many of those numbers are less than 100? Well, what's the biggest number less than 100? It would be the number right before it. So the biggest number less than 100 is 99. Well, if I count 1, 2, 3, 4, and so on, I know that 99 will be the 99th number that I say, right? And we can look back at question 2, right, to understand why. If I start from 1, then the 99th number I say is 99. And that means if I look at all these numbers, 1, 2, 3, 4, 5, 6, and so on, 1 would be the first number, 2 would be the second number, 3 would be the third number, 4 would be the fourth number, 5th, 6th, and so on. And 99, which is the last number I would say before I get to 100, is the 99th number. And so there are 99 numbers less than 100. Now, you might know about fractions, you might know about negatives. In either case, I'm sorry. If you know about negatives, there are infinitely many numbers less than 100. If you know about fractions, same deal. But let's just say positive numbers that aren't fractions. So 99 numbers. And now I'm wondering how many of those numbers have just one digit. Okay. If you don't know what a digit is, here's the number 237. That's a digit, that's a digit, and that's a digit. Here's the number 6. That's a digit. So you can see here that 6 actually has just one digit. And I want to know how many numbers in total less than 100 have one digit. And again, we're not counting 0. So those numbers would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, and there are 9 of those. So I can just do, so there are 9 of those. And that gives me an answer to the second question of 9. Now, a sort of extension problem is if you write out the numbers from 1 to 99, and then you take out those one-digit numbers, how many digits do the rest of the numbers have? So if you think about that, that'll be helpful for your Math Kangaroo test. All right, question 9. Look at the number sentence right here. So 2 plus 1 plus 4 plus 5 plus 2 is 14. So try changing the first plus sign to a minus sign. What's the new value? Try changing the second to a minus, the third to a minus, fourth to a minus, fifth. Okay, so pause, try it on your own, and then I'll jump into it. So let's try it out. If we change the first plus sign to a minus, we get 2 minus 1 plus 4 plus 5 plus 2. Okay, so 2 minus 1 is 1, 1 plus 4 is 5, 5 plus 5 is 10, and 10 plus 2 is 12. Okay, if I change the second minus sign, we get 2 plus 1 minus 4 plus 5 plus 2. Okay, and that's going to be, I don't know if I want to give you guys that question. Okay, well, in any case, yeah, this will come out to 6, though it's tricky for people that don't know about negative numbers. So if you're stuck on that, you can skip it. And then we have 2 plus 1 plus 4 minus 5 plus 2. So 2 plus 1 is 3, 3 plus 4 is 7, 7 minus 5 is 2, and 2 plus 2 is 4. All right. And then if we change the last plus to a minus, we get 2 plus 1 plus 4 plus 5 minus 2, which would be 2 plus 1 is 3, 3 plus 4 is 7, 7 plus 5 is 12, 12 minus 2 is 10. So what do these numbers have in common? Can you figure out why? Interesting. Well, what do they have in common? 4, 6, 10, 12. I'll pause, let you guys think about it. Maybe you already figured it out. And what they have in common is that, well, there's a couple of things you could say. They're all less than 14. That's a perfectly valid answer. There's something else that they have in common, which is that they're all even. Okay, they're all even numbers. They end in 2, 4, 6, 8, or 0. And let's think about why. Well, 14 is even, okay? And if I know that 2 plus 1 plus 4 plus 5 plus 2 is 14, well, if I change this plus to a minus, this plus to a minus, what's going to happen is I'm taking away 5, right? Because I'm getting rid of the plus. And then I'm taking away 5 more when I added a minus. And so what I end up with here is actually 14 minus 5 minus 5, right? And if I subtract 5 twice, that's the same as subtracting 10, right? And because 10 is 5 plus 5, it's an even number. And so no matter what, I'll be subtracting an even number, right? The same thing goes if I were to replace this plus with a minus. I start with 14. I take away 2 to get rid of the plus, and then I take away 2 again to add in a minus. And so I would have here 14 minus 2, which is 14 minus 4, right? And 4 is even because it's 2 plus 2. And so if I subtract an even number from an even number, I get an even number. We'll talk about that a little bit more later. So that's all I'll say about it for now. Okay, this will be the last question of the video, and then I'll show you guys the last 5, which are a bit more challenging. And yeah, that'll be that. So if a building has 15 floors, which floor is in the middle? Well, here's what I can do. I can just draw all 15 floors. The 15 is not that many. I mean, it's a little bit annoying, but that's fine. We've got 1, 2, 3, 4, 5. You might have noticed that I'm drawing the building sideways. That's because that's how much room I have. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and now to figure out which one is in the middle, we're going to do an important strategy. What we're going to do is we're going to say, okay, well, we'll just work in from the outside. So we can go 1 in, right, and then we can go in another, and another, another. And if we go in from the outside like this, we'll eventually hit the middle of the building, which is right here. Okay, well, which floor is in the middle? 1, 2, 3, 4, 5, 6, 7, 8. The answer is 8. The 8th floor would be in the middle. And this is especially important because we briefly talked about last week the median, the minimum and the maximum and the median of a set of numbers. We talked about it really briefly. But as it turns out, if I number the floors of this building from 1 to 15, then the middle floor is the median of the numbers from 1 to 15. Okay, so that'll be all the problems for this video because it's getting pretty long. What I'll do is I'll show you some more questions that you can work on. So question 11, Richard starts with the number 11. He doubles his number, then triples it, and then cuts it in half. Let's just do number. So maybe you don't know what doubling is or tripling. You can ask your parents. I'm sure you're going to do that. And question 12, 36 plus 22 minus 19 plus 94 plus 3 plus 19 minus 22 minus 94. It's a mouthful, but there's some special tricks that you can use to figure that one out. Something that you might notice is this. There's a minus 19 and a plus 19. And if you think about what happens when you take something away and then give it back, then maybe that will be a hint about how you could figure this one out. Okay, 13. Lakshman's father was 27 when he was born and 25 when his older sister Lakshmana was born. How much younger is Lakshman than Lakshmana? So, yeah, you can think about this. If Lakshman's father was 27 when he was born, when Lakshman was born, 25 when his older sister was born, then how many years older is his older sister than he is? Right, I guess that's the question. How many years after being 25 would Lakshman's father be 27? That's what you could figure out. And you may want to employ a subtraction for that one. Okay? 14 and 15, I think, are like harder than 13 by a solid amount. So let's look at those briefly before I wrap up. 14 says there are 5 states in the country of Decaland. There is a road connecting each pair of states, and none of the roads overlap. How many roads are there in total? So what you should do is draw it. Draw all 5 states, draw roads between them, and then count the roads, because there's not actually that many. And it's hard for me to tell you a better way to do it, as long as you're in first grade, second grade, or kindergarten. Okay, and then the last question, Rachel adds up all of the numbers from 1 to 100. Davy adds up all of the even numbers from 1 to 200. True or false, Davy's sum is twice Rachel's. So what I'll do if you want to work on this at home is I'll tell you that the answer is, and I'm about to say it, so pause the video if you don't want to know the answer, but the answer is true. And what you should do is write out the first few numbers that Rachel adds up and write out the first few numbers that Davy adds up and just look at them, compare them, right? And see, would this indicate that Davy's sum is twice Rachel's? So that'll be all for these practice questions. You guys can expect a Math Kangaroo test later tonight. And yeah, with that in mind, I'm going to go ahead and sign off.